Right, for anyone that's interested, first things first, I apologise for anyone that I upset with my last videos on MIDI playing devices. This is my MIDI playing device for my use, for myself. Whether I market it in the future is a different matter. At the present moment in time, all I'm interested in is getting myself up and running to go into my Dean keyframe player to allow me to play MIDI files on my Dean organ without interfering with the organ. Don't believe in cutting into the pipes and midifying a traditional organ, so I'm going to do it by a reverse keyframe. There's the size, that's the width obviously, that's the height, and that's the depth. I've got a circuit board in it very similar to that one, but this one's for a 24 display with a header like that. Keys are there, that's the keys that just plug on the other header that you see there. But this one here can take, this board in here, the new board, this was the old one, can take that display or that display and a different range of keyboards, so that will always remain the same whichever model I decide to build. So in other words, it's a multi-purpose one. Anyway, it's beside the point. Demonstrate the actual boot up screen. Now you can see it says by Simon, Mr. MIDI 2. That's not how the original software screen splashes. I've changed that because I wanted this to read in the middle and not to one side, so just changed the display a little bit. Changed all the features and the buttons. This is the guy that originally brought it to the market as a open source project, and it's there for anyone to download and play with it and do what they like. I may even do a tutorial on that, of how to download it, how to program your IC, and what stuff you require to start modifying the software if you want to. You can download a piece of software called a hex file, hexadecimal, which you can just put straight onto the chip, straight in, and will work you know, quite well. If anyone's noticed, there's a little plug there on mine, and that goes in because I program mine directly with an ISP. That will plug straight into my RS232 port, and then I can just program the chip on the fly instead of using the bootloader on the SD card. I just find that easier. I've got used to that over the years. But I can also program it, the chip, out of the system just by plugging it into that, and that's my own brew, if you like, programmer. Anyway, that's that done. Another little feature of mine, as you can see, it said edited by PT Radford. That's me. I edited the software that's within this particular one, just to show you that, you know, it's not difficult to do. And I can now take the card out of mine, and if I want to reboot it, don't need to do that of course now, because I can just change it, stick a different card in it, take the card out. As you can see, it'll go into default mode because there's no card in it. Put the card back in and it'll automatically reboot it. The same time as it does that, it also reboots the John Whale board as well. Slight modification to do that. That's a J Omega parallel port, MIDI output, so MIDI goes in, outputs go out to mechanical devices. I've got LEDs on this one. Well worth every penny, that board. Cracking piece of kit. Right, let's demonstrate it. Find a piece of music that might be interesting to show you the speed and tempo changes on. Right, we push that. If you watch that there, you'll see the speed change. That's down. Tempo, in other words, and we can take that up. obviously it will go higher and lower than that, but it starts to trip my computer out. My computer doesn't like it, throws a bit of a dicky fit. It's a slow computer in my shed. But it's not the device or the software, it's the actual computer that does that. Now go on and show you changing the transpose. So we'll press the file, and you've seen the way I altered the speed. To alter the tempo, finger on menu, yeah, not a very good video, not a very good song to demonstrate on. You probably noticed me struggling to work these buttons. I'm going to change them. I'm having the card up there, Infinite Wisdom. I was originally going to mount it vertical, which would have been quite easy to get to, but I now want to do it horizontally. So now that's in the way, so I'm going to move that up to there, make a new front for it. There's no record on it. I've removed the delete. And I think I've already explained I'm going to change these around, the menu buttons. I want to be able to go up and down through the menus on them, and then make any alterations within the menus with them. In the same way as I've removed the record button and made it into a menu shift button, and I've removed the delete buttons, and they don't do anything apart from the menu shift up and down now. So a few things have changed on it. This one's also got the internal oscillator is still working, so if we go through the menus very quickly, I think I've already done this. The menu, this at the present moment in time is using the internal oscillator. I want to use the external oscillator for greater accuracy. So when this comes on next time, this manual calibration won't be on there. There'll be nothing there because it won't need it. It might say automatic, but it doesn't really need to. All you need to know, we're using an external oscillator rather than an internal clock oscillator. But apart from that, that's the little MIDI project up and running. I think I've explained to you most of what I can do. There isn't a lot more I can explain. It's just all you've got to view it as an MP3 player that happens to play MIDI files for running our pipe organs. As I've said, it's got a external power, no internal, because this is designed to be built in the front of my little hand-turned organs, which I don't happen to have at the moment. But on this particular device we've got the facility, via a little socket, where I can plug in an external crank sensor. When you turn the handle on your organ, the music will start to play. When you stop, the music stops. You speed up, the music speeds up. You slow down, the music slows down. You come to a stop, the music goes into pause. So trying to put a little bit back of the traditional organ. You will have to go back to having control over your organ in the same way as a hand cranker does with a buck or a roll organ, like the John Smith one. If anybody's interested in it, email me and I'll just send you all the details of where you can get all the information from to build yourself one. And I'll even demonstrate if somebody's, if anyone's specifically interested in knowing how to do it. I'll do a quick demo on how to download it, what software you want, what parts of the software you need to play with and which ones you need to leave alone, what parts do what job, in other words button control, and how to edit some of those. I ain't going to go into detail with it because it's if you don't know about program software, it's a nightmare, or can be a nightmare. You get one thing wrong and it can naff the whole thing up. But you can download a straightforward hex file for one of these, but it's got all the record and all the features that you could ever want on one of these devices in one package. But it does mean it's a little bit more complicated to work, but it works. If you're out there, Simon, I'd like to say very much appreciated for all your work and effort. Extremely good coding, well chuffed with it, not a lot you can improve on, and I hope you like my project.